Morning. So good morning, everyone. Hopefully my voice stands up to this. So Captain Alex, Commander Kyle, Davis, Himanshi, Jordan, Jake, Lemon Juices, Moretta, Robert, Potato Evo, Red Helix, Rubber Slayer, Rezok, Sapphire Gates, Standing Wave, Tap Daddy. Good morning, everybody. Probably hearing an echo. Okay, I got rid of that. Okay, so we have a little bit of makeup to do from the week before spring break to help everybody get finished with Lab 7. And then we'll move straight into Lab 8. So normally what will happen is I will, on the Tuesdays, kind of talk about the overarching concepts for the week, and then on Thursday I will do hopefully a well-paced, sort of a slow walkthrough of that week's lab. So apologies in advance because some of you probably don't like to get all the spoilers like this, but since I don't have the ability to stand over your shoulder and sort of watch you work and step in and help you, I feel like my best option to make sure everyone gets what they need is to just walk you through it. So you still have the projects, and those are still sort of independent work. So you still do have sort of plenty of space to work the problems on your own. You can also work ahead since all the labs are posted. So if you want to do that, hold on, I'm already getting a scratch in my voice. You can always work ahead, or you can wait to view the video instead of attending the broadcast. You can wait to view the video until later. You can always email me questions, and of course you can use chat to ask questions. Don't be shy about that. So, but what I will do is kind of very quickly, since we lost Tuesday this week, very quickly I'll tell you what the concepts are that we're dealing with, and then I'll go into Lab 7, and then probably take like a minute break, because I bet I'll be out of tea by then, and then we'll do Lab 8 together is my plan. So let me bring my notes up. So this is CSCI, if I can type, CSCI 21 for the 26th. All right, so the concepts. So we're learning how to use standard vector, which is a dynamic array of sorts. And what I mean by that is it grows as you add things. It shrinks as you remove things. So that's what I mean by the vector being a dynamic array. It grows as you add things. It shrinks as you remove things dynamically. A traditional array in computer science is a fixed size collection. Sorry, my voice is really roughed up. A standard array is sort of the fundamental collection in computer science, and in most languages, that is a fixed size collection, meaning if you create it to contain 10 items, it can't grow and it can't shrink. It will always be 10 items. A standard vector, on the other hand, will grow every time you add things, and it will shrink every time you remove things. So it's dynamic in that sense. So that's the star data structure of the week. We're also dealing with strings, which are also, but they're kind of a collection of characters, which we talked about before spring break. So strings are also in here as well. It turns out that strings are very similar to arrays and vectors, so I'll point that out when we're taking advantage of the fact that strings are themselves collections. So more generally, what we're trying to do is introduce you to some of the basic concepts of the C++ standard library collections. Most of them have a size function, as an example, almost all of them, you need to be able to iterate over them, meaning to process all elements in the collection. The traditional way to iterate an array, as an example, is a for loop in most languages. It's got honey in it, but it's not doing anything. So we're looking at how, using the size, how do you iterate different collections? So that's, for now anyway, sort of the big stuff. And then we're also doing use your own functions. That's kind of Lab 7 stuff. So what I've done is set up Lab 7 to reward you if you figure out how to use the functions that you yourself have created as a part of the lab. And I'll point that out when I'm doing it so you see what I mean. The concepts in Lab 8. There's really only one concept in Lab 8, which is creating a class to manage a collection. So what you're going to be doing for pretty much the rest of the semester is you're going to be writing code that manages collections of data. You can think of it as different ways of implementing databases in C++. But what this usually means is when we say managing collection, what we usually mean is having a private member that is a collection, which I'll point out to you on Lab 8. Having functions that perform CRUD. And I'll tell you what CRUD means, but it's a computer science-y thing, so you should know what it is. So CRUD. The C part of CRUD means to create, or often we'll say add an element to a collection. The R part means to read or retrieve an element from a collection. The U, you could probably guess, is to update an element in place in a collection. And then the D part is to delete or remove an element from a collection. I'll point it out to you when these things are happening. But anyway, that's Lab 8 is going to be doing this CRUD stuff as a means of creating a class that manages a collection, which is much of what the rest of the semester is. So I will remind you of these things after the 1 minute or so break between labs. But now I'm going to open up and start having my crack at lab number 7. And feel free to use chat to ask questions if you have any. I feel like my camera angle is not the best for you, but probably good enough. It's not like you need to see me really, is it? That is slightly better. Okay. Don't let me forget also. If I forget, let me get this where I can see it. If I forget, you probably can't read that, but I need to ask you about setting up a Slack or a Discord channel for the class if you have an interest in that. So if I forget, that's the thing that I'm going to do right at the very end after I've gone through everything else is poll everybody in chat about using Slack or Discord to give you an additional means of communicating with me and other people in the class. Okay, so where were we at? Oh, this lab. So Lab 7, and I'm not going to bring up the, come on, man. Lab 7 has 4 files in it, so it has a word list. This will be input that the program uses to test the code. It has lab7.cpp, which is unit testing? Did I mess up the screen for you at all? A little bit. A little bit. Okay. Lab 7 is the unit tests. Functions.h is the header file, and I created all those headers with documentation about what each function is supposed to do. And then functions.cpp is where you implement the function. So we're going to start having a crack at that. So the way I go about this is I usually take all of the function headers and copy them from the .h file into the .cpp file. So here they're all copied in here in the CPP file. I have my include for functions.h so that all the definitions are read. I usually strip the comments out at a point, although for now I'm going to leave the comments in so that I know what to do with the functions. All right, so here's my workflow. First thing I do is I remove the semicolons and set up the blocks to be filled in with code. And I'm just going to go down. Actually, let's do one function at a time. So what you're about to see me do is called stubbing the function. And stubbing a function means that you make it so that it will compile even though it's not actually doing the job it's supposed to do yet. So my first step is I'm going to stub it out. The main problem with this function is it's supposed to return a vector of strings. And to stub a function that returns a value, you have to return a value that matches. So the way I'm going to deal with this is I'm going to create a vector of strings called result and then return it. Hopefully all the, if you, please in chat, if you see anything kind of not working right, or if you see me make a mistake, please jump in. Okay, so this is called stubbing the function. It doesn't actually read a file. It doesn't do anything with the file name. But what it does do is it returns a value which is enough to satisfy the compiler. What it returns is an empty vector. It'll satisfy the compiler, but probably not the test. So that's a stub. And I'm going to go down through and just stub them all out. So I can get rid of this string processing comment. So to stub out this to upper, I have to return a string. So I will just make myself a string result and then return that. That will satisfy the compiler. It probably won't pass most of the tests. And then I'll just kind of rinse and repeat. So to lower also returns a string. So I will make one. When I come back, of course, I'm going to have to do the code to make the result. This one returns an unsigned integer, digits. So I will make myself an unsigned integer called result, and then return the result. Now I'm going to speed up a little bit because I think you get the idea. Plus you can watch the video later and slow me down. This one also returns punctuation, so I will make myself an unsigned integer, zero it out to start because that's good practice in C++. So these are all stubs. There's just barely enough code in there that the compiler will let me get away with it even though I know I'm not going to pass most of the tests. This one also returns an unsigned integer. I can remove these sections because I know this is the vector section. So now I'm down in the vector function. So also an unsigned integer. So same thing. What I'm trying to do by stubbing is just get to a compiling state. Yes, Jack asked about the semicolon at the end of the function. Not only can be, should be deleted. So just get rid of it. Good question. That semicolon is only there for the function headers in the .h file. Oh, by the way, one thing I didn't point out, these functions, let me get that file open. These functions in the .h file, they're not inside of a class. So I'm not doing anything : over here because they're not inside of a class. So yeah, to stub a function so that I can get to where I can get an initial compile just to feel good. Get rid of the semicolon and then create the block for the implementation. All digits. If I can spell, signed, int, result. I'm leaving the extra blank line because that's where I'm going to go back later and do the work. All punctuation. Not everyone works this way, but I like to sort of always be compiling or near to compiling. So that's why I'm doing this stubbing, just so I can immediately try to compile. And then I'll focus in on one function at a time. All right, so there's all my functions stubbed out. So now I'm going to go to my terminal and I will compile. I'm going to do a listing here just to show you that there's two .cpp files. And to do a compile, I'm going to have to compile them both. So when I do G++, I need to compile functions.cpp, my function implementations, and the unit test code all at once. I'm also going to change the name of the output executable to be lab7.exe. Oh, I don't have a catch. Why don't I have a catch? Let me get a catch real quick. My computer, even on my relatively decent laptop, still chews away at that catch file. Okay, so now if I run lab7.exe, it's going to run the unit tests, and I'm going to fail most, if not all of them. That's what I expected because all I did was stub out the functions. But it did compile and it did run. I'm just failing everything, but that's what I would expect to have happen. So now I'm going to start attacking these functions one at a time. We've already done read file. This one's fairly straightforward, but you're going to see it again. So what this function's going to do, it's going to open a file of a particular file name, load each line of that file into a vector, and then return the vector. So this will be, do we have the usings for this? We do. So stream input file, I will call it. So remember that when you construct input file with the file name, it attempts to open it all at once. So then you immediately make sure that it did get open. So if input file.is open, then it's okay to proceed. If the file doesn't open, by the way, then an empty result comes back, which is what you would want. Okay, so now we need a string to read each line of the file. So this just gives us a place to store each line as we read it from the file. And then we'll use a while loop while we are still getting lines from the input file and storing them into that string. So this get line will basically kind of return a false when there's no more lines to read. So it takes care of the problem of reading all the lines for me when I put it in a while loop. So while I'm still getting lines, so I'm getting a line from the input file and storing it into this string. What I'm going to do with that is push it back, push that line back onto my vector. So if you remember, the way you add so the name of my vector is result. Next line is a string, so result is a string vector, so I can push strings onto my string vector. So result's going to grow. Every time I read a line, it will grow by 1, and grow by 1, and grow by 1, and grow by 1. So there's that function, I think, implemented. So what I do is I immediately go back and recompile and see if I'm passing any tests now. So part of this is I want to make sure the code I wrote compiled, and the other part is I want to see if I'm now passing any tests. I have passed some tests. I'm going to run this with the dash s, dash little s. Should show me, all right, so there I passed one. Here I'm passing some. I'm still failing a lot, but I am passing some now. And it's compiling. So one function at a time. All right, work my way down to uppering a string. So I will do it the way I do it, which is so I'm going to use the for each style of loop here. So input is a string. So if I for each loop a string, I get characters out. Some of you might remember that if I put an ampersand in here, I actually have a reference to the character, and now I can make changes to it. So I want to overwrite that character with the this is a standard library function to upper. It is not the same as my to upper, which takes string. This to upper takes a character. So I'm going to upper the character, and then I'm going to overwrite it. And since the character is a reference, I can overwrite it in place. So I'm going to save that, and I'm going to go back to my terminal and recompile. See if I'm passing any more tests. I think I was passing 7 before. I don't know where you would get that from, unless you change something. Did you change any of the files? No. So Sapphire, let me come back to that question. But first, so functions having the same name in C++, you can have functions with the same name in C++ as long as the arguments are different. So a function to upper that takes a string is legal to exist alongside a function called to upper that takes a character, because that's a different argument type. If you're getting a pragma once in main file, I don't know why that should happen unless you change something. So let's go through the files real quick. So functions.h has a pragma once at the top of it. Functions.cpp just has functions.h at the top of it. And then lab7.cpp just has this at the top. I feel like something must have changed if you're getting a warning. But if it's only a warning for now, just ignore it. Warnings you can ignore for now. Okay, compiled. I'm hoping to pass No, I'm still only passing 7, so that's not enough to pass more, but it did compile. Okay, so to lower, well, that's going to be easy. So I'm going to grab references to the characters in the input and overwrite them. And since it's a reference, overwriting C with the to lower of itself will work. And here's the same thing. So this function called to lower that takes a string is legal to exist alongside a function to lower that takes a character. C++ can tell them apart. Okay, if you didn't change anything, then for now just ignore the warning. It'll be okay. I'm pretty sure I'm not going to pass any additional tests after to lower, but I am going to go compile it real quick. And it's not real quick, but one function compile, one function compile. I'm going to go ahead and run the test, though, after I do each function, just to see if I happen to magically be passing something. Not yet. Oh, I see the problem. Okay, I am failing them because of bad code. So I'll show you over here. I'm seeing the tests on line 22 and 23. I expect to be passing those, and then I realize where my mistake is. So let's go fix that. So I need to fix to upper. So the first thing I need to do, in fact, the only thing I need to do in to upper, two things I need to do. This result here, I'm going to make result as a copy of the input. That's how you do that. Now result is a copy of the input. And then I will process the result in the loop instead of the input. So same change in to lower. So in to lower, I will make result as a copy of the input. And then I will process the result string in the loop, which should have me passing some tests now. Yeah, so now I'm passing 11, so that's good. All right, on we go. Returning account. Now I am, by the way, this to upper that I used with the character and this to lower that I use with the character, those are standard library functions. I just happen to remember those. We went over them on the Tuesday before, I think. Maybe even the Thursday before that. But I think the week before spring break, we went over to lower and to upper. So digits, I'm going to use the same... and I'm going to use standard library functions that I happen to remember. So I'm going to process the input. I'm not taking a reference to the input because I don't need to change it. I just need to look at it to see what it is. And then I can use a standard library function called isDigit. So I get a character, and if it's a digit, then I increment my result. And then I'll go test that. All right, so I'm passing 2 more. I was passing 11, now I'm passing 13, so I'm pleased about that. I'll do punctuation now. Same idea. So I will use the for each style of processing the input. I'm not going to grab a reference because I don't need to alter the characters. I just need to read them to see which ones are punctuation. I'm again going to use a standard library function called isPunct. So if the character I get from the input is punctuation, then I will increment my result. All right, I'll build that and run the test again. So hopefully everyone notices I'm working on one function. I stubbed them all out so it would compile, at which point when I tested, I failed everything. And then I just go and I hit one function at a time. I compile it and I test it. So now I'm passing 15, whereas before I was passing 13. Vowels. This one's a little bit trickier because you have to be clever about it. But I'll show you what I'm going to do, which is I'm going to set myself up a string that has all the vowels in it. Y, notice the comment says just A, E, I, O, and U. Hopefully you recognize that the reason why this string has big A, E, I, O, U and little A, E, I, O, U is so it will be case insensitive. So that's now what I'm going to do is I'm going to take the characters from the input and then I'm going to look to see if I can find them in my testing string called V. So take each character from the input. I don't need it by reference because I'm just looking at it. I'm not going to change it. Then I don't like this V. Let's call it something else. I'll call it all vowels. All right, so I have a character from the input. Now I'm going to grab in sequence each vowel that I'll call V from the all vowels string if the character and the vowel match, the character is a vowel. Does that make sense? So if the character from my input, I can find by looking through the all vowels, well, that is a vowel. So I found another vowel. The other thing I can do here is make my program more efficient by breaking. This break breaks the nearest loop. So the nearest loop is this inner loop. So once I've found a vowel from all vowels that matches my character from the input, I can increment the result and then I don't need to look for any more vowels because I found it. At that point, when I break out of this inner loop, I'm returned to the outer loop and the next character is drawn from the input. That's how I would do this problem. And I'm going to compile and then rerun the test and see if I pass more than 15. All right, now I passed 17, so still going all right. All characters. Let me squish this up. So all characters just means the length of all the strings. So this is one of those where you sort of try to be clever to reuse other functions. So I have a different argument. So now I'm in the vector section. So I need to think, instead of collections of characters, I need to think collections of strings. So the loop now is to loop through, grab each string from the vector V. So this is the vector V up here. That's the incoming vector. So I will grab a string from the vector and I will simply grow my result by the size of that string. That's it. Because it just says count the characters. Well, that's the count of characters in a string is just the size of the string. So all characters of all strings in this vector should just be take the size of each string in the vector and accumulate plus equals a result. Go build and test. Normally, by the way, I'd go a little bit slower through this, but I'm trying to sort of cram 2 labs into one day. So that's why I'm going a little bit faster. Now I'm passing 18, so that's one more. All right, so when you get to this vector section, think, can another function sort of help me solve the problem? In the case of all characters, it was simply the size of the string that solved the problem. Now for all digits, I need to be more clever because there's no digit counting function in the standard string class. I'm still going to loop through, by the way, and grab strings out of my vector v and accumulate a total by doing something with the s. So what I need to know is how many digits are in s that I add to my growing total. And some of you already know this. I just wrote a function for that. I wrote a function called digits up here that, if given a string, returns a count of the digits in that string. So down here, right here, in all digits, if I pass my s to my own digits function, I get a count of the digits in that string, and then I just accumulate those onto my result. So this is an example of the concept of using your own function. Why not just use the function that already does that job and accumulate the results from a whole bunch of strings in a vector? So build and run again. So I'm passing 19, and I was passing, I think, 18 before. Yeah, so I'm passing one more. No doubt you can see where this next one's going to go. Punctuation. Happily, I have a punctuation function. So I wrote this lab to encourage you and to do this and to reward you for doing this, which is to reuse your own functions. And also so you can sort of see this for loop pattern repeating. Notice I'm not drawing the strings by reference because I don't need to change them. I just need to read them. So accumulate the result by using my own punctuation function on that string. So now I'm up to 20. I was at 19, so now I'm passing 20. You know where this one's going because it's the same thing. Don't need a reference to the string because I'm just going to read it, and then I will accumulate a result by using my vowels function on that string. So I get each string, count the vowels, and accumulate the result. And then by looping over the vector for all the strings, I get the total of all the vowels and all the strings in the vector, the collection. So now we're passing the whole test. All right, so let's see, it's 11:42. So I would like to, I'm just about out of tea and I need some water to keep my voice going. So I'm going to wait a minute or so and then I'm going to go, but anyway, I need about a 2-minute break. So I'm going to go get some water, come back in about 2 minutes and do lab 8. Does anyone have any questions for me though about lab 7 before I tuck that away and go on to lab 8? Now I did go fast, but I will post the video, of course, at the end so you can go back through it. That's correct. Yeah, so Jackass are both lab 7 and lab 8 due by tomorrow. And yes, my goal is to use the weekend to get all the scores recorded. So if I can get it before I get up on Saturday morning to work, that's best for me. So yes, lab 7 and 8 by tomorrow. Correct. I'll post the video, but not the source. Yes, Lab 7 and Lab 8 will both be due tomorrow. Now, once I come back from break, we're going to do the walkthrough on Lab 8, and then I'll post the video immediately after we shut down here. So you'll have the video immediately on YouTube. Okay, yeah, you can go back later and you can pause the video on all the spots. Yes, if you have errors and you just can't work it out, email me and I'll try to answer it. If you get a wall of errors, by the way, usually what works for me is, so if I get a tiny number of errors, I usually start at the top of the error list and work my way down. But if I get a wall of errors, I usually start at the bottom and work my way up. But yeah, you can. If you get a wall of errors and can't work it out, let me know. But the whole solution is here in this video, so hopefully that will also help. And it should be that you can pause the screen on the different segments. Okay, give me a moment. I'm going to go get a glass of water, and I'll be right back, and we'll do Lab 8. So if you need a break now, it'll take me about 2 minutes to do this.